Hello, this is Coach Miner for AP Pre-Calculus. We are on section 1.12, the second day of this. So this video is really just more or less of not new information from the previous 1.12. All the transformations are still the same, nothing being added here, but just different ways these questions may be asked. So let's get rocking and rolling at this thing. Okay, so first up in this first slide, you see you got transformations of functions. This is a nice little overview of everything we've done with vertical translation, horizontal translation, vertical dilation, horizontal dilation as well. This is all just review stuff for you in a nice little picture as well. So let's just go ahead and scroll right on down here. And then this will be our sixth example that we have of this section. We had our previous 5 examples on the previous notes. Okay. Here we go now. So we have a table here that gives us values of p, expected values, and we're going to let h of x equal 3p of 2x minus 1. And we're going to find the following values here. So if you can see, we have p, but then h looks like it's going to be a transformation of p. And we have a transformation going on the inside for the inputs, and we have 2 transformations on the outside for the outputs. Okay, so it looks like that we have a horizontal dilation by a factor of 1/2 because of that 2x in the middle. That looks like we have a vertical dilation of 3, and then we're going down 1 afterwards. Okay, so for h of 1, we're actually going to do this a little bit simpler than just using transformations. We are just going to plug in. So h of -1 is equal to 3 times p of -1. So 2 times -1 is -2. And then minus 1. We're going to use our table, plug everything in, keep it simple. Not much transformations going on for this first problem. So p of -2 is going to be right here. So p of -2 is equal to 1. So we're going to get 3 times 1 minus 1, which is 2. All right. Next one, we got h of 2. So we're going to plug that in. We're going to get 3 times p of 2 times 2 is 4 minus 1. Using the table, when x is 4, p is 3. So we're going to get 3 times 3 minus 1, which is going to be 9 minus 1, which is 8. Next one, last one for this example. We have h of 0, which means we're going to plug in a 0, which is 3 times p of 0. I don't know why we drew a parentheses in front of p. 3 times p, I'll clean it up. 3 times p of 0, and then subtract 1. So p of 0 is this one, right? Oh, I lied. Don't listen to me. Okay, now you can listen to me. X equals 0 is right there. So our p value is -1. What just happened to all my, why did everything move over? We're going to completely try this again because I have no clue what happened to all that. Writing right there. All right, p, 3 times p of 0 minus 1. So p of 0 is -1, so we're going to get -3 minus 1, which is -4, which is about it. Not much going on with transformations for this one, but you can see I try to explain how the transformations comes into play here. If we had to rewrite what's the transformation of h, we could by looking in there. But all we had to do there is just plug in and get values. All right, example 7. Function g is constructed by applying 3 transformations of f in this order: horizontal dilation by a factor of 3, vertical dilation by a factor of 4, vertical translation by -7 units. We know that g is going to be a f of b f x plus c. Find the values a, b, and c. So a is going to be our vertical dilation. So a is going to be our vertical dilation of 4. So a is going to be 4. B is going to be to the inside, so it's input, so it's going to be a horizontal dilation by a factor of 3. So B is going to be input is going to be opposite. So B is going to be 1/3. And then we'll do green for C. So C is going to be the one that's the translation, vertical translation by -7 units. So C is equal to -7. Okay, moving on down. Okay, example 8, another table here. AP loves them some tables. Table above gives values for H at selected values of X. Let K be A, H of B of X plus C, where A, B, C are positive constants in the XY plane, where K is constructed by applying the it's like almost the same problem. Where K is constructed by applying the three transformations in this order: horizontal dilation by a factor of 1/2, vertical dilation of 3, vertical transformation by 1, and then we're going to find K of -6. So now we're going to put what we just did in the two previous problems together. Okay, so I need to find the values of A, B, and C, and then I can plug in a -6 into my table right here to find this out. So let's go ahead and get to this. So let's find A first. So A is going to be my vertical dilation. So A is 3. I didn't mean to cross that out. Just happens. B is going to be my horizontal dilation by a factor of 1/2. So B is going to be equal to, flip it, 2. And then C is going to be my